Hello, physics class, it's Mr. Ng, and I wanted to do a short video on the very last page of your momentum packet. Here, this question wants you to know how long it takes, the stopping time for all of these cars in different scenarios. The first thing you should do is find the initial momentum, P initial. If you remember, P initial or momentum is just mass times velocity. For instance, this is just 3,000 times 10. So this one has an initial velocity of 30,000 kilogram meters a second. And look, when it smashes into this barrier, it's going to have a momentum of 0, right? Our P final, our momentum final is going to be 0. So that means this 30,000 is our change in momentum, also known as, that's right, J, right? Our change in momentum is our impulse. And if you remember, impulse is force times time, meaning the more impulse you have, given the same force, because it's the same barrier, right? The barrier is putting out the same force each time. You didn't change the wall, right? It's the same force. So as we have more impulse, we're going to have a greater time. So here, this one's 30,000. Let's try this one. This is 2,000 times 20. This is 40,000 kilogram meters a second. So D is going to take a longer time than A. Why? It's got a larger impulse. Hello, physics class. This is Mr. Ng, and some of you were having problems with the very last page of your packet. Your last page has one review problem. This one problem about distance and force, it's not about momentum yet. Instead, this is our last unit about energy. When we have distance and force, we're talking about work. Work is equal to force times distance. And you should know that work is also the change in energy. And if you observe the scenario, we have situations where things have a mass and things have a velocity, moving energy. So we should be thinking about kinetic energy. And if you recall, our equation for kinetic energy is 1/2 mv squared. So really, please find the kinetic energy in each one of these situations. I'll do it twice for you. Here, the kinetic energy for A is 1/2 of 1,000 times 6 squared. If you do it right, you got 18,000 joules. Or let's do this one. If we found the kinetic energy of D, this is 1/2 of 1,600 times 4 squared. So 1,600 divided by 2 times 16. I got 12,800. So this is only 13,000 joules. This one is 18,000 joules. So I know that it's going to take A longer distance than D, right? You're just ranking it. The more energy it has, the longer it takes for it to stop, the more work it has. Does that make sense? Thanks for watching.